The broadcast is now starting. All attendees.
Coming on video here for a bit. Hope you can see me. My name is Peter van Dalen, and I will be your trainer for this exam prep for the AWS Certified Cloud Practitioner exam. Now, first thing that I want to point out here is this is going to be for the CLF-C02 version of this exam. What does that mean? We are introducing a new version of the exam, a second version. Up until to send any questions, and my colleague will answer them. And we'll probably be sharing a bunch of information through the chat function, but the questions function is for you to ask questions. All right, let's get going. So like I said, this is all about a certified cloud practitioner, or as we sometimes call it, the CCP certification. And in order to know what this is all about, let's start by looking at this website. This website is all about the certified cloud practitioner. You can see, by the way, in this little corner here on the top right, that yes, indeed, the new version will be available from the 19th onwards. This website is where you typically get started. This is where you can actually schedule an exam here. This is also where you can have a short link to prepare for the exam, and it gives you a bunch of information about this exam. What do you need to know? Well, it's going to be 90 minutes when you do the exam, and there will be 65 questions, which will all be either multiple choice. I would say a majority will be multiple choice, and then some of them will be multiple response. In case you haven't really done a lot of these exams, multiple choice very simply will give you 4 possible answers. One of them will be correct, only one. Multiple response will ask you for more than one answer out of typically a list of 5 or 6 answers, and they will ask you 2 or 3 correct answers. We will always make it very clear whether it is a multiple choice or a multiple response. And we will also make it clear how many responses we want in a multiple response. You can see the cost here as well. So as you can see, 65 questions, so 90 minutes. That means that one of the first things that I always recommend people to do is read the question properly, obviously, but don't dwell too long on these questions. There are, out of the 65 questions, 50 questions that are actually scored. Why is that? Because we change our bank of questions continuously. We are introducing new questions. We are updating our questions. In order to do that, we need to make sure that the questions are written properly. So we will bring out new questions, and we will first bring them through a test phase. During that test phase, there is no score attached to the question, so that if the question were not to be 100% correct or deterministic, it wouldn't affect your score. All right, so when you're going to read the exam guide, which obviously is where you should start, then you will see all of that. We'll see the different steps on how to prepare for the exam actually in the slides. And you can see here as well some information about the exam updates. So going back here. There we go. So yeah, you can then prepare for the exam using Skill Builder. So let me go back to my slides for a second. There we go. So there are 4 steps that we identify when preparing for any AWS certification exam, really. Specifically, obviously, we are focusing on the cloud practitioner here. First things first, review the exam guide. Very important. Sign up for access to Skill Builder. Now, when you go to Skill Builder, I'll show you Skill Builder in a second, but when you go to Skill Builder, there's 2 ways you can access it. There's a free account that you can set up, or you can go for a paid account. Obviously, with the paid account, you will get more resources. Now, wherever it is relevant, I'll try to point out what the difference is between the free and the paid ones. But even with a free account, you will get a whole lot of resources to your disposal. And then enroll, of course, and take an AWS certification official practice question set. Now, that's the first thing that we typically recommend you to do, is to start with the practice question set. Why is that? This is just a little, you can see it here actually, roughly 20 questions that are very similar to what you will get in the exam. Why do we ask you to start even though you might not really have done any studies? Because that will give you a good understanding of what kind of questions you can expect. Now, through this course, as we're going through this in the next 2.5 hours, we will do some of these exam style questions as well. We'll go through them and then I'll explain a bit what to look for as you're going through those questions. But these will help you to get a feel of what style of questions you can expect. So once you've done that, once you've done step number 1, you then go through a potential list of resources that you can take to help you prepare. And now there's going to be a Cloud Practitioner Essentials, or CPE course. That's a very essential one to do. Course, and then you can do a getting started with Cloud Essentials as well, focusing on things like global infrastructure, storage, and pricing. And then, of course, try to gain some hands-on experience. Now, this is something I always recommend people to do as well. The exam itself will not ask and you need to know what they do. Having seen them in action, maybe set up an EC2 instance, try to set up a VPC subnet, and then a VPC, and then set up an EC2 instance inside of one of the subnets. All of that will fundamentally change the way you look at those services. So I highly recommend to get yourself also some hands-on experience. You either can set up your own account, or AWS account, or you can go again through Skill Builder by doing Cloud Quest, Cloud Practitioner. It's a play-based tool that allows you to run around in a virtual world and will ask you to do certain, they will ask you certain questions, and they will ask you to do certain tasks in a lab style environment. It's really fun to do. I've done it myself. And the Cloud Practitioner one is part of the free resources, by the way. All right. Let me, then step 3, what we then recommend you to do is go through the exam prep course, the official exam prep course, which is kind of like the Skill Builder associate of what we are doing here today. Now, there's a standard and an enhanced course for that. The enhanced course will have these additional resources. By the way, you have a QR code there if you want to go straight into it. The ones here with the little wildcard symbol, these are all part of the enhanced course, which is only part of the paid subscription. All right, so at the very least, you will have some 4 hours of videos explaining each of the domains, which we're also going to go through now of the exam. And then finally, once you've done all of that, what we recommend you to do is take one of the official test exams. Now, the official test exams, you can see here as well, practice exam, we call it. The example here is one for solution architect, so you can ignore that, but there's a practice exam for Cloud Practitioner as well. If you go for that one, you will get the real deal. It's 65 questions, just like in the real deal. There are real questions. There will be a timer, and then you'll get a score at the end. This is the ultimate test to know how you are doing. If you go through one of these and you do have a good score, then you know you are ready. So in order to find Skill Builder, just going back here to, you can go to the main site, https://skillbuilder.aws, which will explain you a little bit what this is all about. So you can see here that you can even start selecting things by a role, by product. It talks about those 4 steps as well, as we just saw in the slides. And the part that I find really important is you have all these certificates here. As you can see, all 12 of the certificates are here, and you could click on one of them to actually give you the resource or give you a link to the resources relevant for this exam. Once I'm in, once I have my either free or paid account, I will be at explore.skillbuilder.aws, and I'll have a, you can see here, a search function that will allow me to start looking for any additional resources. So if you're going through all of this and you think, oh, this thing about DynamoDB, that sounds really interesting, I'd like to know a little bit more, you can just start typing in DynamoDB and you'll get resources based on that. There's some filters that you can use as well to filter out what kind of resources you will get back. But as you can see, got a bunch of things here. Industry Quest, for example, is there as well. Here you go, Cloud Quest, Cloud Practitioner. There we go. That's the game-based one. The jams, only part of the paid subscription, and then some exam preparation as well. So again, I'll be having a few more than you. All right, so there's a lot of resources. So please use it. It is there for you to use. All right. Now, the course outline, the 4 domains that you need to know for this exam is domain 1, cloud concepts. Kind of makes sense that we start with something like this. So what is the cloud? What is the cloud architecture? That accounts for around 24% of all questions. What do I mean with that? Well, the domains aren't equally divided. So the questions will be divided with a kind of a weight. So roughly 24%, of questions will go to cloud concepts. Domain 2, security and compliance, important, obviously, 30%. And then the domain 3, cloud technology and services, which is very much a huge list of services for you to know, 34%. This is the biggest domain of all. And then we end up with domain 4, which is billing, pricing, and support, which is 12%. So that's the lightest domain. All right. So we'll go through all of the domains, and they each have like subdomains or subtask statements. So starting with cloud concepts here in domain number 1. So again, if there are any questions, please feel free to reach out to my colleague via the questions function. All right, so first things first, we will define the benefits of AWS Cloud. It's quite important that you know that. And then identify the design principles of the AWS Cloud. This will refer to the so-called well-architected framework. Quite an important one to know, both for this exam and even more so for the Solution Architect Associate, if you're interested in doing that one. 1.3 is then understanding the benefits and strategies for migration to cloud. So we'll see what we call the 7 R's. And then 1.4 is understand concepts of cloud economics. All right, start with defining the benefits of AWS Cloud. So an important question really to ask yourself is, what is cloud computing? So it's important that you can formulate a definition for that. And so I invite you, if you have like a definition yourself, I invite you to put that in the questions tab as well. But I will go ahead and go through 5 really important features of what cloud computing should be. In other words, for AWS to call themselves a cloud computing provider, we need to have the following. On-demand self-service. So in other words, when you log in, again, I do recommend you to have your own account. It gives this very unique perspective on the experience. If you have your own account and you log in and you want to set up, for example, an EC2 service, which is our virtual machine service, then you can do that whenever you decide to do that. So it's completely self-service. You don't have to ask us to set it up by next week or something. There will be nobody of AWS involved in that whole process. It's completely on demand when you need it. We will require access to the network. So from wherever you are, you will access your resources over an internet connection. So this is where the whole thing of cloud comes in. Instead of those resources originally being in a on-prem physical data center that maybe you owned, now this will be somewhere in the cloud. It will be reachable through an internet connection. In other words, they're actually in our own data centers. That's where they physically are. You access them over the internet. We will do resource pooling. That means we have a whole lot of resources there. We make sure that we have more resources available than we actually need for individual users, so that more users can use them, but also that if we require more, that we can enable more and more resources. Very important for me, one of the more important ones is the elasticity. And we'll talk about that very soon in more detail. But elasticity is all about the fact that we can scale our resources, that we can make our resources highly available, so that if something does happen, for example, if the demand for our resources increases, we can automatically add more resources. Automatically being a really important word here. This should normally not be a manual process. We'll come back to that. And then resource usage being monitored and built, very important as well. Built, of course, but monitored as well. So monitored has a lot to do with this elasticity. As the demand for our service hopefully increases, that would be great. We want to increase the resources. That's that whole idea of elasticity. But in order to know that we're actually having the amount of resources that we need, that our usage is efficient, we need to be able to monitor the resources. And so we start by monitoring, which will also lead to correct billing. And billing is very important from your point of view as well. By keeping an eye and an awareness of your bill, you know what you are doing with your resources. See that we could set up something like, for example, a budget. A budget will allow us to give ourselves a bit of an alert if we are going over a certain threshold in our spending. All of this can be set up. So first things first, AWS has what we call a global infrastructure. This is a lovely screenshot. And the global infrastructure consists of multiple elements. Now, we will revisit this a little bit later, but let's introduce some of the main elements here. Regions. What is a region? Well, it represents an area somewhere on the planet. So I'm myself in Melbourne, Australia, so I will use that one as an example. If I would look at Melbourne, the region of Melbourne, by the way, Melbourne, the official name of the Melbourne region is AP, Asia Pacific, Southeast 4. And that's the structure we typically use. So within that region, we've got 3 availability zones. Availability zone 1, 2, and 3. Most regions that we have around the world will have 3 availability zones. There's a few exceptions, but this has become the general rule. An availability zone in itself is what we call a logical data center. What do we mean with that? This could be one gigantic building, one huge data center, or it could be a combination, a collection of buildings that form a logical data center together. For all intents and purposes, you can look at availability zones as 3 huge independent data centers. They are interconnected by our own network, and they are far enough from each other so that if something were to happen with one of the availability zones, and a lot of stuff can happen, whether from massive power outages to flooding to Godzilla stomping on the data center, if something like that happens, it hopefully will only impact one of our availability zones and not all three of them. So if you build up your infrastructure for high availability, that will mean that your resources are divided over the 3 availability zones. Something happens with one of them, service just keeps on going. So regions is a collection of availability zones. Availability zones are logical data centers, potentially a collection of buildings to host our actual services. Again, availability zones are data centers, so this is where the servers are running, where you will set up your services. All right. So our infrastructure will always be designed, or should always be designed, for high availability, fault tolerance, and disaster recovery. So with high availability, we want to design for minimal downtime. With fault tolerance, we design for zero downtime. And then for disaster recovery, say, okay, what if something really disastrous happened? How will we recuperate from that? This is having a process in place, a plan to recover from sufficient disasters. So let's have a quick look at that. So when we talk about high availability, for example, we would have an instance, and let's say this is an active instance. Don't worry too much about all the other names for the moment. If you already know this, awesome. But this is an EC2 instance, which has a security group, kind of like a firewall protecting it. It is housed within a VPC, or a virtual private cloud, which is then within the AWS cloud. So we've designed this for high availability, which means, okay, let's say this is a service or an instance that our users are accessing to. If something were to happen, we could have a new instance that we can spin up. Maybe we have it ready as a standby, and we then spin it up or activate it when we notice that there's something wrong with the active instance. So this means that, yes, our service will keep on going. However, there might be a slight glitch. Bringing this back to that global infrastructure that we saw, if we then make sure that the new instance is in a different availability zone, we are taking advantage of that redundancy as well. By contrast, fault tolerance then, which designs for zero downtime. Again, we got an active instance. But this time, the instance that is taking over when our active instance fails is already active. This would be a brilliant setup where, again, divided over multiple availability zones, we would have something like a load balancer in front of our instances, where automatically requests are being directed to any available active instance at that time. And then disaster recovery means designing systems that operate through a disaster. So this is the very big question. What if something truly disastrous happens? For example, what if we lose connection to an entire region? The example given here is the US East region. If that's the case, do we have a procedure to fall back to another region, US West, for example? I'll use the example as well here in Australia. We do have 2 regions. One is Sydney, which has been around for quite a long time. Melbourne is a much younger region. We could, for example, use Melbourne as a fallback region for our service if it's set up in Sydney. Same here, US East, US West. They actually have multiple regions, even in East and West. But the whole idea is that you have a plan in place, and the plan could consist of things like, and we will go through some of those later on, having the right AMIs ready. This is the images that we will use to set up our EC2 instances. Having CloudFormation templates ready. CloudFormation will be a template that allows us to set up automatically a whole infrastructure. So if we've lost an infrastructure and we need to quickly set up the same infrastructure in another region, having the correct CloudFormation template ready will save us a lot of time. And a lot of stress, of course, as well. When it comes to scaling, which is part of the elasticity story, there's two types of scaling really, vertical scaling and horizontal scaling. What do I mean with that? Well, with vertical scaling, we typically do not change the number of units that we have for computing. Again, the units that are being displayed here are EC2 instances. An EC2 instance is a virtual machine. So there are a huge amount of EC2 instances. You'll see a link to the EC2 instance types coming along, I think a bit later in this presentation. But if you look at it, we're looking here at the same type, the T2 instance, but with different sizes, micro, medium, and extra large. So here we could do what we call vertical scaling by simply saying, okay, I have one server, one EC2 instance, and what I'm going to do is change the size, which means I will change the capacity of this instance. Size is directly related to the number of virtual CPUs that you might have. So it will also be linked to the memory, but there's a direct link between size and the virtual CPU. So as I'm increasing the size, I'm actually increasing the capacity. Horizontal scaling is different. I'm not inherently changing the type of unit. So let's take here a T2 micro, which is a fairly small instance type, but I'm going to change the amount of them. So in this case, I could go from only one instance to 3, for example. This lends itself very nicely to automation, where we could use something like an auto scaling group that could help us scale out, add more instances, or scale back in, remove instances. And we can keep scaling to 6 if that's required as well. So horizontal scaling requires us to use an auto scaling group. Now, again, we could have all those services behind a load balancer, the application load balancer here as an example. I'm going to assume that most of you are aware of what a load balancer does, at least on a very generic level. The application load balancer will be looking specifically at protocols of what we call the OSI layer 7, typically HTTP or HTTPS. So we can actually enable sticky sessions on those load balancers so that any request that is coming in for the same session will always be sent to the same server. That way you have a consistent server that is handling your requests. If not, that would mean that every time the same end user, for example, is connecting to the load balancer, the request could be sent to another server. So application load balancer, sticky sessions, interesting concept to have a look at. So elasticity in the end is all about auto scaling plus horizontal scaling. And so horizontal scaling, we just explained, adding or removing the amount of instances in this case that we have, but we do that in an automated way. To do auto scaling, we will need monitoring. We'll need to be able to watch certain parameters of our infrastructure to know whether it's time to scale out or even to scale in. And as we will see as we're going through this, interestingly enough, scaling can be used both for efficiency, adding more capacity if we need it, but also for cost optimization. Next task, identifying design principles of the AWS clouds. So this brings us to the well-architected framework. This is an important, really important framework where we are gathering best practices. Obviously, we have been using AWS, we as in Amazon as a whole has been using AWS resources for a very long time now, and we also have a lot of customers. From all those deployments, we call pillars. You can see the 6 pillars here on this drawing. Operational excellence, so this has to do with the day-to-day operations of our infrastructure. Security, don't have to emphasize that that's important. Reliability, well, we're talking a lot about high availability and fault tolerance. And then of course, performance efficiency and cost optimization. I was just mentioning how those two could be handled by similar services. Remember our auto scaling group, for example. And then of course also sustainability. Each of the pillars and the framework in general has design principles as well. As you can see them here, again, my colleague will share a link to the well-architected framework. I do recommend you to go over that one and look at the different design principles, for example. So there will be overall design principles like stop guessing your capacity. We need monitoring to know what is going on. Test your systems at a production scale. This is a very important one as well. You don't want to be testing your application, your workload in a different environment than you're going to be using when you're going to run in production, because that way you can't test properly. Automate architecture. Allow for changes in your architecture. Use data to make those changes. Improve through game days before you get all excited about this. This is not like a LAN party or something to just have a bit of fun. These are really serious tests. They're typically very strict, very related to security, where we try out what will happen if, for example, one of our resources is no longer available. And then run testings. So going into one, operational excellence. Again, if you go into the well-architected framework website, you'll see that there are design principles there, like performing operations as code, make frequent, small, and reversible changes. I like that one a lot, instead of doing one big leap. Refine operations procedures frequently. They don't just accept that things are the way they are and everything will work fine. Anticipate failures, like we just saw, and learn from all those operational failures. This is also really important. As a trainer, I find this really important. Share what you have learned within, for example, the larger organization. Security, a very strong identity foundation will be important. Make sure you can trace everything. Talk about services like CloudTrail, for example. Apply security at all layers. It's not just one thing. For example, identity foundation, truly important, but that's not the only thing you need to do. You need to set up the necessary firewalls, whether it is directly in your VPC or maybe a web application firewall. And there's many more security applications available. We'll go through them soon. Automate security best practices. Some of those detective security services will help you detect potential threats to your infrastructure. They are extremely useful, extremely powerful services to use. However, if all you're doing is detecting those threats and you do not automatically have some remediation attached to it, you won't really get that much value out of it. Because as humans, we don't have the speed or the bandwidth even to be dealing with all these security findings in a manual way. Best thing to do is automate reactions. At the very least, sound the alarm if something is going on. Protect data both in transit and at rest. This is all about encryption. Encrypt both at rest and in transit. Keep people away from data. It's probably the funniest one in all the design principles, but actually really important. You try not for people to directly work with the data. Why is that? Because we are not very consistent. We will make mistakes. That is a reality. Whereas if we interact with our data through, for example, a application, the application has been written, hopefully been tested, it will be extremely consistent. So try to avoid directly touching your data. And I think we all know that data is these days the lifeblood of most companies. And then prepare again for security events. Reliability, automatically recover from failure. We're just talking about that. Test those recovery procedures, please do. Scale horizontally to increase workload availability and scale over different availability zones. Just want to add that there. Stop guessing capacity. Kind of talked about that at the very beginning as well. Yes, a very important one. You can't really do the scaling without monitoring. And then manage the change in automation. Again, automate. You don't want to do that manually. Performance efficiency, democratize advanced technologies. What does that mean? Well, it basically means, again, if you're part of a larger organization, first of all, learn about different technologies within AWS, but also share that. Again, I like that a lot. I love the idea of sharing knowledge. This is very important as well, so that you have a more consistent way of doing it. Remember, we are evolving our architecture. So as we're learning new services or new technologies, and that changes all the time, see if you can implement, see if it can add value to what you're doing. Go global in minutes, very important as well. We have that global infrastructure. So if you need to have a global presence, you can do that. Use serverless architectures. They come with a whole bunch of advantages. There's no management of underlying servers. It scales automatically. It's highly available without you having to set that up. Experiment more often. Try things out. It's all on demand anyway. So you can set up a little environment, try something out. If it's nothing, then by all means. And consider mechanical sympathy. So as we are exploring new technologies, we will see that this will have an effect on how we do things. And that will have like a cascading effect as well. Cost optimization, we're actually going to go into details a bit later in this presentation, but it's all about the ability to run systems to deliver the business value, what you're after, but at the lowest price point. And finally, sustainability, our sixth pillar, understand your impact. Now that in itself is great, but you have to also establish sustainability goals. Now, when I go about your impact, for example, if you use a lot of machine learning, and yes, machine learning, generative AI, it's been big, it's been in the news everywhere. We are also super busy with that. But there's one thing you have to realize from pure sustainability point of view is that the training of those large language modules or foundational models, as we call them, those new massive models, they literally cost a lot of energy. They're extremely heavy to run. And so take that into account when you're setting up your sustainability goals as well. Utilize your resources properly, so maximize your utilization. Anticipate and adopt for new, more efficient hardware. We're constantly coming up with new stuff. So keep an eye on what's new so that you might change your architecture and start using hardware that is probably much more efficient. Use managed services, again, to be more efficient in what you're doing, and then reduce the downstream impact of your cloud workload. So be aware of that impact. 1.3, understand the benefits of and the strategies for migrating to AWS clouds. So first things first, we have what we call the Cloud Adoption Framework. Again, you will see an interesting link coming your way, which will help you. And there's quite a few things going on there. There's different capabilities or points of view really that we're looking at this. So business, people, governance, platform, security, and operations. These are the so-called foundational capabilities. But we also look at in domains like technology, process, organization, and product. So technology is maybe the first thing you think about. That's not all. And the advantages that you will get is reducing business risk, improving your ESG, your growing revenue, because cloud adaptation framework will lead to a more agile environment where typically applications can be changed, new software can be released much faster. And so that whole idea of agile, you've no doubt heard of it. It really gets to its own when you are using something like the cloud. So by the way, you might think, why do I reduce business risk? Well, we'll have improved reliability, increased performance, and an enhanced security. And then improving your ESG, or the environment, social, and governance performance. So that's become a very important type of reporting that most larger organizations will be doing, because you will have a better understanding of your sustainability. There will be much more transparency in what you're doing. And then you also have an increased operational efficiency. will reduce cost, but will also increase productivity. It's all about, like we said, maximizing the utilization. And all of that goes through phases, like envision, scale, align, and launch. Now, this is a big framework in its own. Again, see the link that's being shared and have a good read that you at least understand what this is all about. Now, like I said, we will see the 7 R's. That's what I meant with it. So 7 migration strategies for the cloud. So what are they? Retire. We start with the fun one. As you're migrating existing workloads from, let's say, an on-prem environment to the cloud, it's very, very possible that you'll realize that you no longer need that workload. So you can simply retire it. You might be surprised as you are doing this kind of migration. Typically, the first thing that we do is do a bit of a discovery. You'll be surprised what you will find. So maybe it's time to retire some of them. Retain, just keep them. This is applications that you want to keep in the source environment or applications that are not ready to be migrated. So retain them basically on-prem or wherever they are. Maybe you are planning to retire them soon. So why would we do the effort? Rehosting is then also known as lift and shift. So this is for applications that to migrate without making any changes to the application. We were doing it one way, we're doing it same way again. So typically it's already running on a virtual machine, so we'll run it on a virtual machine. Relocate, that's typically for a large number of servers that comprise one or more applications. And then repurchase, which is a bit of a drop and shop. That's what it's called. That's for applications with a different version or product and provide more value than the existing infrastructure. Maybe reinvestigate the licenses that you're paying. Replatform could be actually after re-examining your licensing, you might come to the conclusion that you want to run all of this on a different platform. So this is more a lift, tinker, and shift. So it's for applications that need some level of optimization in order to be operationally efficient and to take advantage of actual cloud AWS capabilities. And then the last one, the refactor or re-architect, that's a full-on rewrite really of your workload. Sometimes that is the best thing. Sometimes that's the best way to take advantage of underlying architectures. So constantly changing. So which service would you use? Just to give you a few ideas of services that are out there: Elastic File System, EFS, Snowball Edge, S3, for example, simple storage service, or the Amazon Relational Database Service, or RDS. Now, what could we use? Well, S3 is, in a lot of cases, a really good choice when it comes to storing data. But maybe it wouldn't be the optimal one for the low latency requirement. We've stayed very vague here. And S3 also sits in the so-called public zone, so which could potentially add to the latency, especially if you are interacting with it from within the VPC. Snowball Edge in this case is not really what I would recommend. It's great for migrating huge amounts of data, typically from an on-prem situation to the cloud, but definitely not low latency. So probably my choices would be here EFS and RDS. So EFS as a file system, a shared file system, and RDS as your relational database. Then another example here, just going through a bit of scenarios here. So let's assume here that I want to launch a Microsoft SQL Server database in AWS. But you also need to ensure that the database is cost optimized and only a standard license for SQL Server is required. So what kind of option would we have? We could do Aurora for SQL Server. Sorry, for Aurora, yeah, for SQL Server. Could that be a thing? Why Aurora? Because that's a cloud optimized database, and then buy a standard license, or RDS for SQL Server. Or maybe I want to launch an EC2 instance with an AMI and then buy a standard license. Or maybe I want to use a Windows server. But one that already comes with SQL Server installed. So there's a lot of possibilities. Now, this brings us into the realm of AMIs, those images that I was talking about, the Amazon machine images. We've got a lot to offer. Obviously, some of them are have to be paid for, but because they will have some kind of license attached to them. If you launch an EC2 instance using a Windows AMI, you could choose one that is already bundled with the SQL Server standard. You don't need to purchase your own license from Microsoft. It comes with the AMI. So you could possibly choose the RDS database instance that runs SQL Server standard. Yes, that's definitely an option. And then purchase the license. Here you would have to do a bit of checking, but the question was asking for the most cost optimized one, and it probably end up being a little bit more costly. And then Aurora is not an option at all because there is no option to have SQL Server. Aurora only supports MySQL and Postgres. When it comes to data backups, there's a few things in there. Yeah, this is all about storage first and foremost, that we need to store it somewhere. S3 is a really good option. Why? Because S3 is highly available. It has an amazing durability, 11.9 durability. It automatically shards the data over the 3 availability zones within your region. But S3 also has multiple storage classes. So one of them being Glacier is specifically used for archival information. So that can be a really cost-effective solution. And we have AWS Backup, which is a service to help you manage those backups in a consistent way. Again, if you have a larger organization running on AWS, you want to be consistent. You might have dozens of accounts, then you need something centralized to organize your backups. And then finally, understanding the concept of cloud economics. We already saw the well-architected framework. So total cost of ownership. So we are at the cost optimization part here. So total cost of ownership, there's quite a few elements that are part of the total cost of ownership. So first one, operational expenses, also called OPEX. This is very much the cost based on the consumption of resources. So your day-to-day operating costs. If we look at this in a more classic office environment, that could be utilities, printer, toner, coffee, snacks, stuff like that. Then you have the capital expenditure or CapEx, and that's costs that are associated with creating the basically long-term benefits. So this is purchasing a building, servers, the printer that we're just talking about, the toner. Yeah, that gets consumed. It's a consumable, as we say. The printer typically is something that you build buy as an investment. Power backup, stuff like that. So typically CapEx items are generally purchased once and expected to hopefully aid your organizations for many years to come. And of course, you got labor cost as well. And then here interesting is also, what is the labor all about? So just to give you an idea, when we compare an on-prem situation with a cloud situation, your labor cost, there's a lot of labor cost going into maintaining your servers, making sure they are running properly. Whereas if you run into the cloud, all of that is no longer your responsibility. And then of course, there's also software licensing costs that you need to take into account. So CapEx or OPEX, a little tip here for the exam. When you migrate from an on-prem on-premises environment to and from traditional servers to AWS, you're basically trading CapEx, capital expenses, for variable or OpEx. So variable expenses or operational expenses. So we'll dive deeper into AWS services in domain 3, cloud technology and services. And I know I've been mentioning quite a few of these services, throwing benefits at you, tools, features, and whatnot. And it can be a lot to remember and to understand. But as we go through this course, we will continue to identify keywords for different services. There will be a little bit of repetition as well. And obviously, it's up to you to then repeat this again so that it actually sticks in your memory. And we'll try to take topics and concepts and build on each. The deeper you dive into fundamentals, benefits, cloud economics, the more it will all make sense, both for the certification exam, but very important as well for the real world. So we're at the end of our first domain. Let's go through a walkthrough, our very first walkthrough question. We'll have 2 of these per domain. So first of all, why are we doing this? Well, will be one of those opportunities to see the type of questions, like I said in the beginning already, which is the step 1 that we always recommend. So we're doing some of that already here together. So you see what kind of questions you might potentially get on the exam. The questions are not pulled directly from the certification exam, right? So don't memorize or whatever. You're not going to get the same one. This is about understanding how to deal with these questions, but it will be similar. So I want to show you methods I consider to be helpful when you're working with multiple choice questions. The methods help you focus on what you're looking for and help you identify any distractors. Remember, multiple choice, 4 answers. One of them is correct. The others we call distractors. Questions also provide you with additional information. So any questions you feel confident in will reinforce your knowledge. And then if you feel like, okay, wow, that question just went way over my head, great, then you know where your gaps are, and then you know what to work on. All right. So I'll try to follow a certain format where I'll start reading the question. We call that the stem sometimes, but it doesn't really matter. And then I'll identify some keywords and phrases in the stem that show you exactly what you're looking for in the responses. And after that, I'll go through the responses and give you some time to figure out if you can identify the correct response yourself. After you've been given a chance to figure it out, I'll just go through the responses and we'll see why it's correct or why the others are not correct. All right, first question. And I want you to participate in this. Use the questions tab. Which AWS Cloud Architecture design principle supports the distribution of workloads across multiple availability zones? Let's have a quick look. What do you reckon are, this is a very short one, so what do you think is a potential keyword here? Just think about it for a second. Let's have a look. So design principles, remember the well-architected framework. And here we're also talking about distribution of workloads across multiple availability zones. We talked about that as well. All right. So looking here, we can see 4 potential answers. So what kind of design principle is this? Implement automation, design for agility, design for failure, or implement elasticity. A, B, C, or D. Please put them in the questions tab, and then I will reveal the answer. Going once, going twice. Design for failure. I've assumed that this was still one that was kind of like relatively obvious. So we talked about failure tolerance. So automation is a very important design principle, do not get me wrong, but the fact that we are distributing workload over multiple availabilities has less to do with automation. It has to do all about designing for failure, so high availability or failure tolerance or fault tolerance. Agility, no, The fact that we could, for example, come up with a new release or deploy our workloads very, very fast. We're more talking about than maybe new workloads. No, that's not to do with the fact that we have multiple availability zones. Elasticity was probably the one personally I would have come closest to doubt. So this is where you can doubt, but then elasticity is more the actual scaling. Yes, ideally the elasticity, the scaling happens over multiple availability zones. Yes, but the actual fact of using multiple availability zones has to do with designing for failure. Cool. Next one. System admin is reviewing a group of servers that were found during a portfolio discovery. All the servers are migrating to AWS. The servers have no current owner. And that happens more than you think. There is very little traffic to the servers. Which migration strategy? Remember, you saw the 7 R's. Which of the strategies would you use, or would you suggest to the sysadmin? So it's a group of servers. We are migrating it all to AWS. We found that via that discovery phase. I told you about that one. There's barely any traffic. So these are 4 of the 7 options. It's one of these. So I'll give you again a few seconds to think about it. Which one would you use? Going once, going twice. Sold. Retire. You might think, oh, wow, that's harsh, isn't it? Well, I hope you realize the first 2 here, rehosting, replatforming, there's work involved there. You know, like especially with replatforming, this is a bit more work. But why would you do work on something you don't even know if it's still being used? You don't even know who the owner is. It's like not an obvious choice. Now you might say, oh, I want to retain, just keep them where they are. You know, like somebody might knock on my door one day. But remember that we said that all the servers are migrating to AWS. Nothing will be retaining. See, this is a really nice example of how a keyword can make it really clear. You might have had a doubt between retaining and retiring. And depending on your own personal character, you might have found retiring a bit harsh. But if the context here is that all servers must go, retaining is no longer an option. All right. Go. That was domain 1. I hope you found that useful. I hope you found that interesting. We're gonna go through domain 2 now. After domain 2, we will have a small break. Security and compliance. Start off by talking about the shared responsibility model, then talk a bit more about understanding cloud security, governance, and compliance concepts. We'll also look at access management capabilities and then identifying components and resources for security. Start with the shared responsibility. This is a typical, this is our go-to example of the model. So, and as you can see, there's this line with the customer on one hand and AWS on the other hand. First of all, it's called the shared responsibility model. I hope that wasn't a big shock that people thought, oh my God, we're both responsible for security now. Yeah, but we are responsible in different ways. To make it very simple, AWS will be responsible. We have the responsibility for security of the cloud. What does that mean? Well, basically, we talked about things like the infrastructure already, the global infrastructure. Well, it goes without saying that the responsibility for that infrastructure is ours and ours alone. Just think data centers. Why would it ever be the responsibility of the customer to secure our data centers? That makes very little sense. So everything that comes about where your service will be running on, that's all going to be our responsibility. All the redundancy that we're building in. Even looking at it from a point of view of compliance, which we'll talk about in a second, but the fact that our services are set up in a way that they are compliant is our responsibility. However, customers are responsible for security in the cloud. Anything that you're running on top of our infrastructure will then become your responsibility. Think again, something we've used a lot as an example, EC2 instance, that virtual machine. Now, a virtual machine runs on a physical host server. Obviously, we're responsible for the physical host server. You don't even know where that one is. It's somewhere in the data center. We're responsible for that. But once you've set up an EC2 instance, once you've set up a virtual machine on top of that host, you need to make sure that you keep that EC2 instance up to date. Is it the latest operating system? Did you install all the security patches? That becomes your responsibility. As you're putting that EC2 instance somewhere in a VPC subnet, did you put the right firewalls around it? We will make sure firewalls are available for you to use. But how you're going to use it is your responsibility. Same with that whole idea of compliance. Our services are compliant with, I don't know, over 70 different international compliance standards. It's pretty impressive. And you'll see some links passing by about compliance later on and about the programs. And that's all very impressive, but you can use the services in a way that they are no longer compliant. So the fact that you keep using them in a compliant way will be your responsibility. All right, so I hope that makes sense, but it is definitely very much a shared responsibility. Oh, sorry. Next, understand cloud security, governance, and compliance. So let's go a little bit deeper into that. So what do you need to understand? That compliance needs for locations and industries differ. So that's why we have those compliance programs. Again, see the links. Now, it changes for industries. There's some classic examples like HIPAA, for example. This is all to do with medical information. So if you have medical data, for example, you need to be compliant to the HIPAA standards. So, look, HIPAA, strictly speaking, is a North American standard for health information, health industry protection, something. It's coming originally from North America, from the United States, but it's being used pretty globally. So, other things like the payment card industry, digital services standard, for example. It's all very important one. If you have any kind of online e-commerce website, you'll probably have to follow that one as well. Again, something that's used quite a lot. Now the locations as well, very interesting from a data compliance point of view. We have regions around the world. However, if you start sharing your data, let's say we put it in an S3 bucket and then we copy it to an S3 bucket in another region. Great for availability. Also great for your disaster recovery. If something were to happen with your original region, hey, we've got a copy in another region. How awesome is that? However, if that second region is in a different country, the local laws of that country when it comes to data governance will be in effect. So that's a really important one to realize as well. So different physical locations, industries, all will have their own compliance. So AWS compliance is, again, a website that you have probably now seen in the chat, where you can find more about the programs, and you can look internally in AWS artifacts for more information about, for example, how our services are indeed compliant with those standards. So they will explain that, but they will also explain what you need to do to remain compliant. It also has reports on the audits that our data centers go through, for example, because we do not allow our customers to visit our data centers. They are hidden. They're basically, I don't know where our data centers are, and I work for AWS. So we're very careful with that. But obviously we can't just do whatever we want. We have to adhere to standards as well. So we have third-party auditors coming in and they will write up a report. The reports are completely available. We're completely transparent there. So and know then where to find compliance information, both on the links that we found that we share with you, and of course specifically in Artifact. Now, when it comes to compliance and security, there are quite a few services. And this is an interesting slide in the sense that when I prepared a few years ago for my cloud practitioner, this was probably the area that I was a bit like, wow, there's a lot of services there. and I'm just quickly looking. Most of them are in there. That's great. This is one where I would definitely make up a list of what services are there for security and what do they do. Because some of them might look alike, or you're like, aren't they doing the same thing? But they will never do exactly the same thing, otherwise we wouldn't have a second service. But there might be a little bit of overlap. But so understanding the use case for each of these services will be very important for the exam. Just quickly going through what we have here. GuardDuty, for example, really interesting one. It's an intelligent threat detection service. So we'll give you all those findings and say, well, look, I've detected that somebody is doing an SSH brute force on one of your public EC2 instances, for example. Or somebody's trying to install malware on your system. All of that stuff is really interesting. But like I said before, the next step there is that you automate the reaction to it. So you should have an automatic reaction. For example, I have in my account a system in place where if GuardDuty detects that somebody is trying to get into one of my EC2 instances, I automatically take the IP address of we call it the actor, which is the hacker, basically, and we put that into a firewall to block access for that IP address to any of my resources. Good. Macie is a really interesting one as well. This is all about personal identifiable information, to looking for sensitive information. For example, in an S3 bucket, you can go through there with Macie to detect what could be considered personal identifiable information. It has become a really important part as well. Web application firewall, together with other firewalls like our security groups, which you've seen on a few slides already, and also the network access control lists. These are simple firewalls. The web application firewall is a web layer firewall that allows you to set up a whole package of rules, like, for example, bot detection, SQL injection, a whole bunch of stuff. A really amazing service. Cognito, this is where we will do identification. Now, instead of identification, and one that could have been in here as well, is IAM. IAM is all about setting up users, roles, so basically credentials plus policies, permissions of what these credentials, what these entities can do. This is typically meant for either people working for the organization, that would be your users, or your own services. Cognito is all about identifying end users that want to access your service. If they need to identify beforehand, we can use something like Cognito. So it's a web-based identifier. Shield and Shield Advanced, this is all about DDoS, distributed denial of service. If you don't know what DDoS is, look it up. I'm not kidding you. You have to be at least aware of what this kind of threat is. It's a very important one. And then you'll understand why it's important that we have a service for that. By the way, these two work quite closely together as well to help you protect against all of these threats. And we've got Secrets Manager, which allows you to have things like credentials safely stored outside of, for example, your application code. Inspector is a really cool one as well, which allows you to investigate vulnerabilities specifically on EC2 instances. So if you got a question about vulnerabilities on EC2, it's probably going to be Inspector. You know, like that's kind of like the giveaway there. There's one more actually that is not on here, which is called Detective, which helps you analyze information from multiple sources and then look for the root cause. So it's a root cause analysis. And then Security Hub. Security Hub will allow you to gather together findings from multiple other services like GuardDuty, for example. But one actually that's not in there is Trusted Advisor. A Trusted Advisor does more than security, but it has a security part to it as well. So all of these things can be then put together into Security Hub. And what is cool there is that you have a central place to look at everything that has to do with security, but you can also set up a lot of that auto remediation from there. And you can look at what your security posture looks like and compare that to some of the security standards and see how you're doing. You actually get a percentage, like, are you 72% there to be compliant with PCI DSS, for example. Encryption is encryption at rest, for which we will typically use a service called KMS. KMS is the key management service. Make sure that you are aware of that. Helps you define cryptographic keys that help you then encrypt and decrypt your data. Encryption transit is all about setting up TLS or SSL. Again, if you don't know what that is, it's quite a well-known protocol. Please look it up. And a typical service there is the certificate manager for that. So be at least aware of what services are going to be helping with that. What more? Well, we need to understand what, sorry, we saw that already. So we have seen all of that, where to find, yeah. And then finally, we add these to the list: CloudWatch, CloudTrail, and Audit Manager. CloudWatch is one of those really, really important. When it comes to monitoring, CloudWatch is there. CloudWatch will monitor parameters, metrics, we call them, from any one of your services that is running. And you can then put alarms on that. It's basically setting on a threshold so that there is an automatic reaction if something like that happens. CloudWatch can also refer to, although it's a separate service these days, EventBridge, which keeps track of events happening in your infrastructure. For example, an EC2 instance is being switched off. That's an event. It's a change of the state of that resource. So yes, it's an event. You can again automatically react to that. Talking about events, CloudTrail. CloudTrail will keep track of all the API calls within your infrastructure. That means every bit of user activity is being tracked by CloudTrail. Super important, especially from a security point of view, to know what is going on in your account. You need to know that. If something suddenly changed, somebody has changed part of the configuration, you need to know who that was, when it happened. The why you probably will have to ask, but still, you can have a bit of an idea. Audit Manager is based on CloudTrail, actually, where it gives a framework for all that information that CloudTrail is gathering to see whether or not, how you're doing again from a security point of view, whether or not looking at all the events that CloudTrail is gathering, that this might potentially pose a threat to your infrastructure. Then next one is identifying AWS access management capabilities. This is a very important one as well. So first things first, some fundamentals. You need to understand that. Why do you need to control access, user access? For some of you, that might be like, that's a trivial question. Of course, we need to do that. But honestly, think about why really. Well, the thing is, the reality is that we don't all need to have the same access. We don't all need to have the same level of permissions. If that were the case, just think about it. Even if we just look at it from one account, we have a bit of an organization, there's multiple people working there. Not everybody needs to have access to all the resources. Like a sysadmin probably needs a pretty broad access, but apart from that, if I'm working like a data analytics, yes, I'll need access to some of the data storages, but not necessarily all of them. Not everything falls under data analytics. So only the ones and the tools that I need to use. For example, I might be using something like Athena to analyze data. Okay, then I need access to Athena. Let's say that I work with data that's stored in S3 buckets, which is sometimes used for setting up data lakes. Yeah, I need access to those S3 buckets. But do I need access to all the S3 buckets? Do I need access in a way that I can read data from those S3 buckets? Or am I also allowed to write, potentially even delete data to my bucket or from my buckets? It's a big question. So what we're talking about here is a principle called least privilege. And really, from a security point of view, this is the most important principle that exists. Only give people the permission people, because we're talking about user access, but whether it's a person as in a user or whether it is a service that is using a role. When it comes to permissions, only give the entities the permissions they need and nothing more. So what do they need to do their job? Basically, nothing more. Let's put it this way, it's better to err on the side of safety and having to add more permissions later on if they truly need it, than the other way around, where people have received too many permissions to begin with and then can potentially do harm. And a lot of times that's not malicious. People just make mistakes. How to control access to your AWS account. So there's multiple ways that we can do that. But the service in this case is the IAM, or the Identity and Access Management. And then the question is, of course, what is an AWS account? Yeah, there we go. So what is an account? Well, again, I do recommend you to set up your own account. There is such a thing as a free tier, which will help you to keep those costs to an absolute minimum with a bit of luck, free. But what happens when you create an account? And basically, to create an account, you'll set up an email address, and then you have to provide a credit card. And then you will get the first entity, which is a root user. Now, again, we'll share a link with you about root users. They have a certain list, and you can see the list here. I'm not going to go through them all with you, but please read that link that explains that there's a certain set of permissions that only the root user can do. So the root user is directly connected to the account. More specifically, the root user is the only user that can delete the account. Kind of an important one. So even your full-on admin, who has basically access to all services, will not be allowed to delete the account. Only the root user can. For that reason, we're not supposed to use the root user on day-to-day activities. Basically, the root user is the account, if you wish, and the root user will create one or multiple admin users, and they will take care of setting up the other users. That's the role of it. And the root user is there at the background, and would obviously recommend you to use things like multi-factor authentication and a very strong password, so that it stays safe and it's only there in case you truly need it for one of these functions. All right. So IAM itself, very important that we understand the different concepts there. First and first, we can set up users. One user basically recommends an actual human being, an employee within your organization, for example, and we refer to this as more permanent credentials. Basically, username and password to get into the console, or a secret access key ID and secret access key that can be used for more programmatic access. What do I mean with that? Well, how can I access my services? I can use the console, which is a graphical user interface. See if I have it ready for you to use or for you to see. Let me quickly. There we go. Quickly going to show you. This is what the console looks like. This is my username. So this is the username demo admin. This is the alias of my account. This is the region I'm in. I'm in Oregon for reasons, don't worry about that. Even though I'm in Melbourne. And then these are the recently visited services. I can just type in the name of a service and go there. Let's just, for the fun of it, go to EC2, for example, click on the name. And I can see there's not going to be much running here. If I were to change this now to Sydney, there might be a bit more, although there's one running instance. There you go. Let's have a quick look. There you go. There's a Cloud9. I have to look up why this one is running again. And there's a few of them that are currently stopped as well. So see, I mean, I can start seeing my resources. I can start manipulating my resources. So that's the console. That's one way to access my services. Another one is the CLI, or the command line interface. Typing in some commands, which I could do from, for example, here. This is my terminal on my computer, on my Mac. So I could do something like AWS EC2 describe instances. There we go. And it's going to give me a list. There we go. There's a lot of information. I obviously would have to tweak this a little bit and format this a little bit, but it will give me an overview of the configuration of the different instances. Basically the list that I just showed you in the console, but with all the information. Like I said, I could put this in a little table to make this cleaner. And then the third way to access it is via the SDK, Software Development Kit, which really means that I can have those API calls, those interactions with my services through my code. So permanent credentials for either